Happy morning, cadets. Now, would like to start today, and I welcome you back for this computer science session. And in our previous class, we have discussed about the objective type questions on computer system overview. Now, we'll move on our next chapter, that is data representation and objective questions on that. As I already said, your objective questions includes your one word answers or multiple choice questions, fill in the blanks, or true or false. So let me revise what exactly the data representation was and what all the contents we have studied in this unit, that is data representation. How data is represented for the purpose of storage, for the purpose of processing, etc. So in this chapter basically we dealt with number systems, that is binary, decimal, octal and hexadecimal. How to convert a number from, how to denote or how to convert a number from one notation to another notation, that is maybe from binary to octal, octal to binary, binary to decimal, decimal to binary, then decimal to hexadecimal, and what are the symbols used in each number system, what are the basis of these number systems, both integral as well as the fractional values, how to convert. Apart from that, we had some encoding schemes, that is how to represent the data, not only digits, each character may be alphabet or a special character. So these encoding schemes are used. So to test our knowledge on these concepts, whatever we have studied so far, let us try out how exactly good we are, right? Under multiple choice questions, the questions are very easy here. Okay, let me take a highlighter here. The value of radix in a binary number system. What do you mean by radix? What is the meaning of this radix? Radix is nothing but base. That base will tell you how many digits are allowed in that number system. Okay, in binary the by itself suggests it is 2, therefore the base or the radix of the number system is 2. Answer is A. Similarly, the value of radix in octal number system. Oct means 8, right? Octal number system. So we will have answer B here, right? The value of radix in octal number system is 8. Similarly, the value of radix is once again, as I am telling you, it is a base. The value of radix in decimal number system is, and we are very familiar with this number system, that is what we call it as 10. Basically this either 2 or 8 or 10 tells us that how many symbols are allowed in that number system. For example, in decimal number 10 means we use the symbols or digits from 0 to 9. In octal 0 to 7. In binary 0 to 1. Similarly here now, let us see that the value of radix in hexadecimal number system is obviously, what may be the answer here? D, that is 16. In binary 2, in octal 8, and in decimal it is 10, and in hexadecimal it is 16. Next question, which of the following are not valid symbols in octal number system? As the radix is 8, the number of symbols allowed are 8, that is 0 to 7. Therefore, whatever the digit value within 7, all are allowed, like from 0, 1, 2, 3, 4, 5, 6, 7. Above the value 7, those are not valid symbols in octal numbers. So accordingly, the answer is 8 as well as 9. These both values are not allowed in octal number system. Okay. 6. Which of the following are not valid symbols in hexadecimal? If you think of the symbols allowed in hexadecimal, that is 0 to 9 and A to F, right? For the value 10 it is A, 11 it is B, 12 it is C, 13 it is D, 14 it is E, and 15 it is F. So 0 to 15 it will be totally 16 symbols. Accordingly, if you think of A is 2, right, allowed, 8 is also allowed, 9 is also allowed, G, okay, it is beyond F, so F is also allowed. Therefore, the question is, which of the following are not valid symbols? So answer is G. G is not allowed in the hexadecimal number system. Question number 7. Which of the following are not valid symbols in decimal number system? As you know that decimal number system allows symbols from 0 to 9. That's how the 2 is allowed, 8 is allowed, 9 is allowed, whereas G as well as F are not allowed in our decimal number system. Hope you understood this, right? Next, question number 8. The hexadecimal digits are 1 to 10. It is not 1 to 0. It should be 10 here. It is a printing mistake. The hexadecimal digits are 1 to 9 or 1 to 0 and A2. Here question itself we should say 0 to 9. Along with 0 to 9, the symbols allowed in hexadecimals are A to what? E, F, G, D. A to F, na? Because once if you take 0 to 9, the remaining symbols are 10, 11, 12, 13, 14, 15. That is A, B, C, D, E, F. So the hexadecimals are A to F, not E, not G, and not D, right? Next question. The binary equivalent of the decimal number is the binary equivalent of the decimal number 10 is dash. Decimal 10 is decimal 10 it is. How the value 10 is represented in binary? Let us eliminate one by one as we apply the rule, that is from the bit side here. Okay, we call it as a weightage. Any digit represented at the last here, it is having a weightage of 2 raised to 0. Next 2 raised to 1. Next 2 raised to 2. Next 2 raised to 3. Suppose if it is 1, 1, 1, 1, then we can add 8 plus 4 plus 2 plus 1. I am writing 8 plus 4 plus 2 plus 1. Okay, at the last digit is 2 raised to 0, that is 1. Okay, in tens place it is 1, means it is 2 raised to 1, that is 2. And it is hundreds place here, if you write it 2 raised to 2, it is 4. And if I write here 2 raised to 3, that is 8. Therefore, it will be 8 plus 4 plus 2 plus 1. That will become 12 plus 2, 14 plus 1, 15. If all the digits are 1, then obviously the value will be 15. Now in this case, let us see now here, what is the value here? 2 raised to 1 means it is 2. 2 plus 0 plus 2 plus 0 plus 0 means the total value of 0, 0, 1, 0 will be 2. That is not the answer. 1, 0, it is, what is the value? Once again it is 2 raised to 0, 2 raised to 1. Once again this value is 2. Now let us check here. As I told you, 8 plus 0 plus 2 plus 0. So 8 plus 2 will be 10. Okay. What about this? Once again it is 0 means 2 raised to 0, 2 raised to 1, 2 raised to 2. So this total value is also 2 here. So answer will be exactly, we can take it as a C, that is 1010. It is a binary equivalent of the value decimal 10. Now the next question, ASCII code is a 7-bit code for dash. What are these? What is the mean by ASCII actually? American Standard Code for Information Interchange. A 7-bit code. What all the things you can represent in that? You can represent letters, you can represent numbers, you can represent other symbols, and all of these. What you can say? You can represent all letters, numbers, as well as the other special characters like your dollar, question mark, any delimiter, okay, and all those possibly we can represent using ASCII. Let us see the question number 11. How many bytes are there in this? Okay. Now, what do you mean by byte? Byte is a sequence of digits. How many digits will be there in a byte? That we have to go to units of measurements. The smallest bit or the smallest the measurement unit is bit. It is binary digit. 1 digit is called as a bit. 4 bits are called as a nibble. Okay, 8 bits are called as a byte. 8 bits are called as a byte, and so on. Kilobyte, megabyte, terabyte, gigabyte, etc. Now if you count how many digits are there here on this question, if you just count here, how many are there in this? You count here. There is a group of four groups of each four digits. Therefore, totally there are 16 digits are present in this. 16 digits divided by 8 means, because 1 byte equal to 8. So 2. If there are 8 bits, the number of bytes would have been 1. If there are 16 bits here, the number of bytes will be 2. So your answer will be B. How many bytes are there in this numbers? Means 2 is the answer. Now question number 12. The binary equivalent of the octal number 13.54. We need to eliminate here one by one. Okay. Now as we did in case of the question number 9 here. Okay. Similarly, now 13. 13 means what you have to do here in 13 case here. We'll leave about the fraction part afterwards. We'll see that. But now in 13, 3 into 8 raised to 0 plus 1 into, okay, if you want to convert it into decimal, 3 into 8 raised to 0 plus 1 into 8 raised to 1. Okay, or else we are writing a binary equivalent. We can replace the 8 digit here by 3 binary digits. Okay, or else the value of 13, how we can write in binary? The value of 13 in binary. How the value of 10 we have written? You can say the question number 10 1010. Similarly, if you would like to write 13 in binary, now let me check here. Okay, 1 plus 2 plus 8. 4 is 0 here. So 1 plus 2 plus 8, that becomes 11. So A is not the answer. So here in B, 1 plus 8, that is 9. It is not the answer. Here 1 plus 4 plus 12. 8 plus 4, 12. 12 plus 1, 13. Okay. So 13, obviously 0.54 will be there. Okay. 1110, it will be a 0.54. So your answer will be 1101.1110. Okay. The octal equivalent of 111010. I am discussing about question number 13 here. As you know that 111 is nothing but 7, right? Why? 1 plus 2 plus 4, and 010 is 1 plus 2 plus 0, that is 2. So this octal sequence represent, or this binary sequence represent the octal value 72, right? Answer is B. The input hexadecimal representation of 110 is, now what is the value of this? You see, if you convert it 1110, okay, if you convert 1110 here, what is the value of this? 0 plus 2 plus 4 plus 8. 8 plus 4, 12. 12 plus 2, 14. But 14, how it is represented? A is 10, B is 11, C is 12, D is 13, E is 14. Therefore, the input hexadecimal representation of 1110 will be E. Not 14, not 15, and not 011. Okay. Question number 15. Which of the following is not a binary number? Which is not a binary number? Can you tell me? 111 is a binary number, obviously. 101 is a binary number, obviously. 000 is also a binary number. 11E, 111E is a hexadecimal number. It is not a binary number. Next, let us move to the next question. Convert the hexadecimal number 2C to decimal. What is the value of this? Once again, the same rule we have to apply here. C into 16 raised to 0 plus 2 into 16 raised to 1. So, if you make 2 into 16 raised to 1, it is 16 into 2, that is 32. Okay. And C is, what is the value of C? 10 A, B, C. 10, 11, 12. So, 32 plus 12 will be how much? 44. Therefore, your answer is C, that is 44. Which of the following is not a valid encoding scheme for characters? We know ASCII. ASCII is the American Standard Code for Information Interchange to represent a 7-bit code which represents letters, numbers, and all other symbols. ISCI is a Indian script code for information interchange for Indian languages we use. Unicode is universal code to represent multi languages over the world. We can represent the characters, whereas ASCII is not a, what you can say, valid encoding scheme. Therefore, your answer will be D. Now let us move to the fill in the blanks here. Very simple questions. The decimal number system is composed of dash unique symbols. How many unique symbols? 10 will be there. Okay. Similarly, the binary number is composed of 2 unique symbols. Octal number system is composed of 8 unique symbols. The hexadecimal number system is composed of 16 unique symbols. The illegal digits of octal numbers are dash and dash. We are talking about the digits. So, the legal digits are actually 0 to 9 in case of decimal, right? In case of octal, we are allowed to take up to the digit 7. Above 7, that is 8 and 9 are illegal digits. The hexadecimal number system recognizes symbol 0 to 9 and 8 to F. This already we have discussed in multi-choice, right? Multiple choice question. Each octal number is replaced with dash bits in octal to binary conversion. We want to convert a octal digit or a octal value number into a binary, okay, equivalent. We can replace 3 bits. Why 3 bits only? We are talking about a octal. Octal means base is 8. 8 means 2 raised to 3. Okay, in binary we can write equivalent 3 digits for a given octal number. Similarly, each hexadecimal number is replaced with dash bits. Okay, how many now? It is 2 raised to 4. That is 4 bits can be represented a hexadecimal number in binary. ASCII is a dash bit code, while extended ASCII is a dash bit code. So, ASCII is a 7-bit code, as we already know, and extended is ASCII. What is the difference between ASCII and an extended ASCII? ASCII will represent 2 raised to 7. 2 raised to 7 means it is 128. Okay, up to 128 characters we can represent in ASCII 7, whereas in ASCII 8, 2 raised to 8, that is 256 characters can be represented. That is the difference between ASCII 7-bit code and extended ASCII is a 8-bit code. Question number 10. The dash encoding scheme can represent all symbols, dash characters of most languages. That is your Unicode. Uni stands for universal. The dash encoding scheme represents Indian languages characters on computers. That is your ISCI, Indian Script Code for Information Interchange. So let us discuss about the last part of this, true or false questions. Number 1. A computer can work with decimal number system. It is false because it works with a binary number system. A computer can work with a binary number system is true. Let us see. So we have discussed so far. The 1 is over, 2 is over. Now about 3. The number of unique symbols in hexadecimal number system is 15. No, it is false because the number of unique symbols in hexadecimals are 16, not 15. The number systems can also represent characters. No, their encoding schemes are used to represent the characters. ISCI is an encoding scheme created for Indian language characters. True. And Unicode is able to represent nearly all language characters. It is also true. So at this point of time we will start, and in my next class I will come with the OTQ with the next chapter, that is Boolean logic, right? So would like to stop at this point of time and would like to continue in our next class. Till then, bye bye.